Are we living in a computer simulation? It's one of the most absolutely mind-bending questions of our time, and it's moved way beyond science fiction into some really serious debates. So today, we're going to dive into a pretty powerful argument that says we can't just find the answer, that it's structurally impossible to even ask the question the right way. The whole simulation hypothesis has gone completely mainstream. You've got huge names like Elon Musk and Neil deGrasse Tyson putting odds on it, which makes it feel like a real, plausible scientific question that we might actually solve one day.
So let's just put the question front and center. Is everything you see, everything you feel, everything you know, just some incredibly sophisticated program that's running on another civilization's computer? It's a really seductive idea, right? But what if that very question has a fundamental flaw? See, systems engineer Ramesh Kalkere argues that it's not just that we don't have the answer yet. He's claiming that we cannot get the answer, ever. Not because we don't have the right technology, but because of a deep structural limit.
Okay, so let's really dig into this, because this is where things get really, really interesting. We're about to explore why this question, which seems so scientific on the surface, might actually be outside the bounds of science altogether.
So first, who is this guy making such a bold claim? Well, Ramesh Kalkere isn't some philosopher just speculating from an armchair. He's a systems engineer with over 4 decades of experience in fields where things absolutely have to work. We're talking aerospace, cybersecurity. His entire career is built on what is observable, what is verifiable, and what is real.
And his conclusion? It's definitive. He argues that the unanswerability of this question is as certain as a physical law, kind of like Heisenberg's uncertainty principle. He's saying he's discovered a set of structural laws that make it impossible for us to know our reality's ultimate nature from our position inside it. So let's get into the first and really the most fundamental of these laws. This is the big one, the concept that the entire critique is built on. It's called the embedded observer barrier. And the law, it sounds simple, but wow, it is profound. An observer who is part of a total system cannot verify the nature of that total system. Think about it. If you're inside the box, you can't prove you're in a box without some kind of reference to what's outside of it. And this is such a great way to make the idea crystal clear. Think about verifying that the Earth is round. That's totally possible, right? Because the Earth is a subset of the universe. We can physically get into space, an external position relative to Earth, and look back at it. But when your target is the entire universe, the totality of everything, well, by definition, there is no outside for us to go to. There's no external reference frame. And this quote just nails the point perfectly. It's a definitional impossibility. The question, what's north of the North Pole, is totally meaningless because the whole system of directions is defined by the pole itself. In the same way, asking for a viewpoint outside the universe is a meaningless request. And this really gets to the core of the problem. Any tools we use to test the universe, our telescopes, our particle accelerators, even our own brains, are all part of the very system we're trying to test. It creates this impossible recursive loop. The system is trying to measure itself with its own parts, with no external calibration. It's like trying to lift yourself up by pulling on your own bootstraps. It just can't be done. But the embedded observer barrier is just the first piece of this puzzle. Kalkere argues it's part of a complete framework of 5 interlocking laws that, when you put them all together, create this totally insurmountable wall against knowing the answer. All right, the second law gets into a core principle of science, falsifiability. Basically, for a hypothesis to be scientific, there has to be some possible observation that could prove it wrong. But here's the problem. The simulation hypothesis can explain away literally anything. And here's exactly how it works. Proponents have what Kalkere calls the design choice escape hatch. Let's say we observe a universe with perfect, consistent physical laws. They can just say, see, it's well-written code. But then if we find a glitch or some weird anomaly, they can just as easily say, oh, that's just a rendering bug. Since any possible evidence can be explained away, the hypothesis can never be proven wrong, which means it can never be scientifically verified. Law number 3 hits on a classic philosophical roadblock, the problem of infinite regress. The simulation hypothesis claims it can explain our reality, but it immediately just raises another bigger question. What about the reality of the simulators? Are they in a simulation too? See, at the end of the day, the simulation hypothesis doesn't actually solve the mystery of existence. It just kicks the can up another level. If you argue that there has to be some base reality out there that just exists on its own with its own laws,
Then you've got to ask, well, why can't our universe be that base reality? It just adds a layer of complexity without giving us a real answer.
Law 4 tackles those big statistical arguments you hear from people like Musk. To calculate the probability of being in a simulation, you'd need to divide the number of simulated universes by the total number of all universes, real and simulated. But what is that total number? The thing is, from our position embedded inside just one universe, the denominator of that equation is structurally, fundamentally unknowable. We just can't get that number. And the final law, this one brings the whole problem right down to the most personal level you can possibly imagine: consciousness itself. This is another perfect example of a recursive measurement problem, where the thing doing the measuring is the very thing being measured. Just look at this parallel. The deep philosophical challenge of consciousness, the I trying to verify the me, is structurally identical to the universe trying to verify itself. You can't get outside of your own subjective experience to objectively measure it, just like we can't get outside of the universe to measure it. It's the exact same barrier, just on two vastly different scales. So, after all of that, what's the real takeaway here? It's not just about the simulation question anymore, is it? It's about a much deeper insight into the nature of science and knowledge itself. We've just walked through these 5 structural laws. Now, each one on its own presents a major challenge to the simulation hypothesis. But when you put them all together, they form this airtight framework that shows that from our embedded position, we are fundamentally firewalled from ever knowing the ultimate nature of our reality. And this right here is the most important thing to grasp. The argument isn't proving that we are not in a simulation. The real insight is that understanding what is fundamentally unknowable is a crucial kind of scientific progress. It's like how discovering that the speed of light is a cosmic speed limit was a huge breakthrough. Discovering the limits of verification is its own major step forward. Which leaves us with one last, really powerful question to think about. Maybe the true purpose of science isn't to find an answer for every single thing we can imagine, but to carefully and honestly map the boundary between the questions we can answer and those that, because of our very nature as observers inside the cosmos, will forever lie beyond our reach.